Differentiability at a point, the algebraic method, is the function given below continuous and differentiable at x equals 1. Okay, so first we look at the continuous aspect. Continuous, which basically means if you plug in 1 into each of these, do you get the same output? It's defined as the limit it's defined as the limit of our function g sub x going toward, as x goes towards 1 from the left. Is that the same as the limit as x goes to 1 from the other side, the positive side of our function? Are those the same? And basically you're just plugging in these values to see if you get the same output. It's important to kind of recognize this is x less than 1, so that would be from the left side. So this would be this one, and then this would be this one if you had to kind of keep track of it. But basically we're just plugging it in for continuous. So let's go ahead and do that. If it's not continuous, then it's not differentiable, so that's easy. So 1 minus 1, so first I'm doing this one. 1 minus 1 is equal to 0. And then this one down here, 1 minus 1 squared, that also equals 0. So yes, it is continuous. And then differentiable is a little bit more tricky. So differentiable, we need to use the limit definition. We're going to a number. So the limit definition is limit as x goes to, in this case, we'll just put the generalized form. G sub, I'll say t for now. That's the variable I'm using. It's x. G sub x minus g sub t. All over x minus t. So we want to do this from both sides, right? From the positive and negative side. And so like I said, this is our, I'll say x from the negative side. This is our x is greater than 1. This is x from the positive side, just to make sure everything links together. All right, so let's go ahead and dive in. So this is the limit as x goes to where? We're going to 1. I'll just go in order, the top one, the negative side. So that's going to be, we plug everything in here. So our function with x in it, so that'd be x minus 1, exactly what you see right here. This is your g sub x, minus g sub t. And I just plugged it in already. So that was, when you plug it in, I think we got 0, right? All over x minus the t is 1 in this case, x minus 1. So that goes away, that reduces, and we get the limit as x goes to 1 from the negative side of 1, which is equal to 1. Okay, let's go ahead and do the other one. The limit as x goes to 1 from the positive side. So our g sub x function is x minus 1 quantity squared. Minus, when we plug it in, we found out I got 0, so maybe I shouldn't erase it so quick next time. And x minus 1 on the bottom. Okay, so it reduces out by 1. So this cancels and this cancels. So when you plug 1 in here, you're going to get 1 minus 1 is equal to 0. Is this the same value? No. So it is not differentiable because it has a different output here, but it is continuous because when I plugged it in, it was okay. So continuous, you just plug in. Differentiable, you have to use the limit definition. So continuous, not differentiable. Same idea. All of these are going to be exactly the same. We're just doing that same process. So I'll do continuous over here this time. Continuous, plugging it in. So you can go through the limit definition like I just showed you, but the streamlined way is 3 squared, which is 9. So that one equals 9 for the continuous. And then on the bottom, 6 times 3 minus 9 is 18 minus 9. And I got 9 on this one also. 9, continuous. Check. All right. And then the limit definition, always practice it. The more you practice it, the easier it gets. So it's the limit as x goes to t of g sub x minus g sub t all over x minus t. All right. You have to use this one because you're plugging in a value. So the limit from the left, that would be this one. So this is where t is from the left. X is less than, yep. So x is going towards 3 from the left side of our function. Our function is x squared minus, so I'm plugging it in here. The g sub x function is exactly this on top. Minus, when I plug it in, I got 9. So you can recalculate it, but we've done the work for continuous already. Over x minus, and then our t is 3. All right, we got a difference of squares up here. So just the top, save a little room here. So just the top turns into x minus 3, x plus 3. Okay, we have an x minus 3 in common, x minus 3 in common. And when you plug 3 into here for the limit, you get 3 plus 3 is 6. All right, so this one turns out to be 6. Let's go ahead and check out the limit from the other side. The limit as x goes to 3 from the other side is our function, 6x minus 9. And minus, the output was 9, over, and then it's x minus our value of focus is 3. And let's see. So got to simplify this one a little bit. So we got the limit, and we got 6x minus 18 over x minus 3. This, we're still going to 3 from the positive side. And there's a common factor. I'm going to change this to red, a little bit easier. So we now have the limit as x goes to 3 from the positive side. There's a lot of rewriting on these. There's a common 6 here. So I'll pull the 6 out. X minus 3 is left over x minus 3. Reduces. And it just output of 6. Output of 6. So what does that mean? It is both continuous and differentiable. So you're going through the process each time. A note though, if it's not continuous, then you don't have to do anything else. It's neither continuous nor differentiable. If it is continuous, you got to go through the process to see how it links together. And then as we get into the shortcuts, you can kind of, there's even a quick way of doing this, but I don't want to jump ahead of ourselves. Okay, and it looks like the rest are very similar.